Good afternoon, everyone. So today we are going to discuss IOQM mock test. Now, obviously, since it's a mock test, that means the pattern is same as the actual one. So obviously, first 10 questions are of 2 marks each, the next 12 5 marks, and last 2 10 marks. Right? Now, IOQM is a different kind of paper. We'll be focusing on 2 things in this video. First is reading of the question. That means interpretation. And the second is the direction that you might take. Right? So obviously I would love that if you can focus on these 2 aspects of it. So without further ado, let's begin with the first question. Now he says an aluminium can is in the shape of a cylinder, which is closed at both ends. Right? Okay, closed at both ends. Fine. Now he is talking about the surface area. Right? Obviously I'll be talking about the curved surface area as well as the 2 circles. Right? That means 2 pi r h plus 2 pi r square. That is given to be equal to be 600. Right? Now he says if the radius were double, its surface area would be 1800. Now radius is doubling, right? So that means instead of r, I have 2r. So that is 2 pi into 2r into h plus 2 pi. Now radius is doubling, so that is 2r whole square. That is equal to 1800. Right? Now if I rectify it, this is nothing but 4 pi r h plus 2 into 4, 8 pi r square. That is equal to 1800. So I have these 2 equations. From this, I need to find out that if instead the height of the can were doubled, the surface area would be this much. Right? Basically, I need to find the surface area when the height is doubled. Right? So that means surface area, and that is 2 pi r h. Now height is double, so that means 2h plus 2 pi r square as well. So indirectly, I need to find the value of 4 pi r h plus 2 pi r square. Right? Now, one method is I can find the value of r and I can find the value of h from these 2 relations, put it and I'll get the answer. But mind it, I can find the value of this expression individually and the value of this expression individually. Right? So, let me take the easier way out. Suppose I want the value of 2 pi r square. That means I do not want pi r h term, pi r h term. I want to eliminate this. I can eliminate it provided I have the same coefficient. Obviously, it's here, it is 2, here it is 4. So, I can multiply this equation by 2. So, this becomes 4 pi r h plus 4 pi r square. That is equal to 1200. Right? Now, I can easily eliminate it, subtract it. I will get 4 pi r square is equal to 600. Right? Now, I want 2 pi r square, that means half of this, half of this. So, this value is nothing but 300. Right? Next, I want this value. Mind it, 4 pi r h. It's directly here. So, use this equation. So, 4 pi r h as it is plus. He says 8 pi r square. Now, 4 pi r square is 600. That means 8, double of it, would be 1200. This is equal to 1800. So, that means you are getting the value of this also, which is nothing but 600. Right? So, in total, the answer is 900. Mind it, he said this surface area is nothing but 15 alpha. 15 alpha. Alpha obviously turns out to be 90. No. Alpha obviously turns out to be 60. Which is the correct answer. Alright. Let's move on to the next question. Now he says let n be 2 raised by 13 into 3 raised by 7. He says how many positive integral divisors of n square are there which are less than n but not divisible by n. Right? But do not divide n. Damn it. Okay, fine. Retry. Cool. Let's move on to the next one. Now he says let n be 2 raised by 13 into 3 raised by 7. You need to find how many integral divisors of n square are there which are less than n but do not divide n. Right? First of all, he is talking about n square. Now, if n is this, my n square is nothing but 2 raised by 26 into 3 raised by 14. Right? Now, he says you need to write only those divisors, first of all, which should be less than n, but it should not divide n. Right? So, I need to talk about the integral divisors. We need to talk about special kind of integral divisors of this number. First of all, let me write the normal divisors. Right? Can you tell me how many integral divisors are there? Right? Okay, let's see. Any divisor of n square either will have the power of 2 or of the power 3 or both of them. So basically, I would have 2 raised power something into 3 raised power something, right? In different ways, I can fill up these parts, and the different ways will give me the different divisors of this number. Now, 2 raised power something. Now, do you think I can put 2 raised power 0? Yes, we can. We can just have some power of 3, right? I can do that. So I can have 2 raised power 0 over here. I can have 2 raised power 1. I can have 2 raised power 2, 2 raised power 3, so on till 2 raised power 26. That means in order to fill this place, I have 0, 1, 2, so on till 26 choices. So that means 27, right? Then here, let me fill up this. Either I can put in 0 or 1 or 2 or so on till 14. So how many choices do I have? 15, right? Now, corresponding to the power of 2, I will have the power of 3, right? So total number of divisors, that would be 27 into 15, which is nothing but 405. Right? Now, he says we do not want all integral divisors. We want those divisors which are less than n, but do not divide n. First of all, let me talk about this thing, less than n. How many divisors would be there which are less than n? Okay. Now, let me think about the factorization of the number. If I need to write the factorization, let me see how can I write it. Now, first factor that I can think of, that is obviously 1. So, 1. Right? And we write 1 into 2 raised power 26 into 3 raised power 14. Right? Corresponding to this factor, I will have this factor. Right? This is how we usually write it, because we count these, and we get the number of factors. Right? The second factor, obviously, I can say that is 2. So corresponding to this factor, I will have 2 raised power 25 into 3 raised power 14. The next factor can be 3. Corresponding to this factor, I will have 2 raised power 26 into 3 raised power 13. Right? Then I can have 6 and so on. Right? Now, by doing this process, eventually I will come to the number n, which is nothing but 2 raised power 13 into 3 raised power 7. Corresponding to this factor, I will have the factor 2 raised power 13 into 3 raised power 7. Mind it, it's a perfect square after all. Right? And then I will proceed further. And the last factor, obviously I will not write it because then I need to evaluate that. Right? In total, I have how many factors? 405. Now, I want those factors which are less than n. Right? Which are less than n. Mind it, every factor which is less than n, for every factor which is less than n, I can find a factor greater than n. Less than n, greater than n. Less than n, greater than n. Less than n, greater than n. Right? In fact, after this, I will not even write the factors. Mind it, because if I write the factor, that factor will be included over here. Right? Okay. So, less than n, greater than n, less than n, greater than n, less than n, greater than n, and so on till I come to this point. This is n, this is n. Right? So, basically, I need to count all of these. Right? How do I count it? Mind it, pairing is already there. There are 405 factors, right? In the last one, this factor is being repeated. So that means just leave this one factor. That means I am left with how many? 404. Right? Obviously, half of these come in this one and half of these come in this one. So that means how many these are? These are nothing but 202 in number. Right? Till now, I have counted those factors of n square which are less than n. Which are less than n. Alright? Alright. Now the second condition, but do not divide n. But do not divide n. Now how should I find those factors among these? How should I find those factors which do not divide n? Mind it, we can write the factors of n as well, right? Let me talk about n now. Now, n is nothing but 2 raised power 13 into 3 raised power 7. Right? I can have the total number of factors of this number, which will obviously be, see, I can have 2 raised power something into 3 raised power something in the factors. This I can fill in, either I can fill in 0, 1, 2, so on till 13. That means 14 ways. Right? Similarly, I can put in 0, 1, 2, so on till 7. That means 8 ways. And this is nothing but 112. Right? We know that there are 112 factors of n. Mind it, this is not a perfect square. So if I am writing the factors, let's see. If I am writing the factors, So it would be something like 1, then 2 raised power 13 into 3 raised power 7, then 2, then 2 raised power 12 into 3 raised power 7, and so on. Right? But mind it, how many factors are there which are less than n but do not, no, which are less than n? Let me count those. Right? Obviously, just one factor is there which would be equal to 1. Rest of the factors would be less than n. So that means I would have 111. These are the factors of n, and less than n. Right? Mind it. Question was, I need to write the factors of n square, which are less than n, but do not divide n. Now, these are the factors which divide n, because I have written the factors of n itself. I want do not divide. So, out of these factors, if I subtract this, I'll be left with those factors which do not divide n. Right? So, 202 minus 111, that will give you the answer 91, which is the final answer. Alright, on to the next one. Now he says let alpha be the number of all quadratic polynomials of this form. Right? Now it is a quadratic polynomial, that means leading coefficients have to be non-zero. So a is not equal to 0. And my form is ax square plus bx plus c. Now he says where ABC comes from this collection 0, 1, 2, 3, 4, 5. Right? So that means A, of course it can't be 0, it can be 1, 2, 3, 4, 5. B, it can be 0, 1, 2, 3, 4, 5, and similarly with C. Right? And he says this condition needs to be satisfied. That means B square greater than equal to AC. Right? We need to find the value of alpha minus 30. Basically, I need to find how many number of quadratic polynomials are there. Right? Now, if I can find out the different values of A, B, C, I can have the different polynomials. Right? So I need to know in how many different ways can I have A, B, and C. Right? Which satisfy this condition as well as this condition. Now, obviously, we'll start with this condition, B square greater than equal to AC. I can rewrite this AC less than equal to B square. Cool? Because I am more comfortable with this in equation, less than equal to. Right? Now, I can see B is either 0 or 1 or 2, 3, 4, 5. So let me make the cases. Then B is equal to 0. Right? AC is obviously less than equal to 0. Now, I need to find out the values, the corresponding values of A and C. Right? The least value of A which is possible. Obviously, 0 is not possible. 1. So let's start with 1. Corresponding to A is equal to 1, I need to check out the values of C. Now, do you think I can put C as 0? Yes. 1 and 2, 0, that is 0. Which is obviously less than equal to 0. Right? Then, you think I can put C as 1? No. Then 1 into 1, that becomes 1. 1 less than equal to 0. Anyways, he says that AC should less than equal to 0, right? Less than 0 as in negative. A and C are positive numbers, right? Obviously, it cannot be negative. That means the minimum value, the only value it can attain, that is 0. So, product of two quantities is 0. Either one has to be A has to be 0 or C has to be 0. A cannot be 0, so we started with C. Right? Now, A is equal to 1, exhaustive. Now, A is equal to 2. We can take that. Now, C has to be 0. Right? 2, 1, 2, 2, none of those satisfies. So, that means now A can be 3, so 3, 0. Then A can be 4, 4, 0, 5. So, from here, I get 5 polynomials. Why? Because A is equal to 1, B is equal to 0, C is equal to 0. That gives me 1 polynomial. So, I can see the different number of solutions over here will give me different polynomials that I am interested in. Right? Okay. Now, next one, when B is equal to 1. So, AC is less than equal to 1. Right? Now, I know that AC is a whole number. So, either it can be 0 or it can be 1. Less than equal to 1. Right? 0 wali case is already लिखे थे हमने 1 0. Now, mind it, I will not write it like 1 0 2 0. What I'll do is I will keep A as 1 and exhaust all the possibilities when A is equal to 1, so that I do not miss out anything. Right? So, when A is 1, C can be 0. When A is 1, C can be 1. It's satisfied. When A is 1, C can be 2. No, this doesn't satisfy. Right? So, 1 2 doesn't satisfy. 1 3 will not satisfy. 1 4. So, 1 5. Yeah. 1 1. A is equal to 1. Exhausted. Now, 2 0 satisfied. 2 1 absolutely not. Right? 2 2 obviously not, and so on. Then 3 0 yes. 3 1 no. 4 0 yes. 5 0 yes. Done. So from here, obviously, I'm getting 6. Right? Let me do one more. So B is equal to 2. That means AC is less than equal to 4. Right? So let's start with A is equal to 1. So 1 0, 1 1, 1 2, 1 3, 1 4, 1 5. Absolutely not. Right? Then let's move on to 2 1. So 2 0, 2 1, 2 2. Yes. 2 3. No. 2 4. Obviously no. Moving on. Then A is equal to 3. So 3 0, 3 1. 3 2. No. Then 4 0, 4 1. Yes. Then obviously 4 2 will not come. Then 5 0. And that is the end of it. Now these are 13 in number. Right? So on similar lines, you can find when B is equal to 3, AC less than equal to 9. You just need to find the solutions. Provided you move in a systematic manner, the answer should be there. Right? This is 5, 6, 13. For this one, it turns out to be 20. From B is equal to 4, AC less than equal to 16, we get 27. Right? Then B is equal to 5. That means AC less than equal to 25, we get 30. Right? On similar lines, you can do that. So in total, how many polynomials? This plus this plus this plus this plus this plus this. This turned out to be 101. So that means alpha is 101. But you don't want alpha, you want alpha minus 30. That is why the answer is 71. Alright. For the next question, the figure is given to us. Now he says angle P is 90, PQ is 24, and PR is 32. Now, since I know it's a right angle triangle, I know the third side, which turns out to be 40. Right? Even if you do not know the Pythagorean triplet, you can see that this is 8 into 3, this is 8 into 4, this has to be 8 into 5. Right? Next thing he says, M is the midpoint of RQ. That means this is equal to this. So, dire is 40, that means this is 20, this is 20. Now, he says NM is perpendicular to RQ, so this is 90. We are interested in the area of this triangle, PNQ. This is a very special type of triangle. Why? Because it is a right angle triangle. The area for a right angle triangle is nothing but half base. I can take PQ as a base into height. With regards to PQ as a base, my height would be PN. Right? Now I already know PQ, which is 24. Right? All I need to do is find out the value of PN. Right? Okay. Now PN is this length. In order to find out this one, I know that this is a right triangle. Right? That means if somehow I get to know this side using Pythagoras theorem, I can find out this one. That means I want NQ now. Mind it, NQ is also involved in some other right angle triangle, which is this one, NQ. Right? If I want to find out this value, this already I know, that means I want to know N. Right? Now, in order to find NM, I need to think about it. Now, NM is involved in this triangle, NRM. Right? What is so special about this tiny triangle? Right? Obviously, 90 degrees there. Also, it shares an angle with the bigger triangle. Right? 90, 90. Shares an angle. That means this triangle is similar to the big one. Right? Maybe I can use this. Now, let me write the similarity statement. So, triangle, I'll start with M because 90 degrees. MRN is similar to triangle. Now, corresponding to M, it has to be P, then R, then Q. Right? Now, I am interested in NM, so that means this one. So, MN divided by PQ, PQ. Do I know the length PQ, which is 24? Yes. Is equal to. Now, which length do I know? RN? No, I do not know. MR? Yes, I know. So, I will use this MR by PR. MR is nothing but 20 divided by PR, which is 30. Right? From here, you can get the value of MN, which is nothing but 15. Right? Now, this is 15. My job is done. Why? This is 15, this is 20. That means this is 25. Pythagorean triplet. Now, this is 24, this is 25. That means this is 7. Done? Just substitute it and you will get the answer as 84. Alright, on to the next one. Now he says in a motorcycle competition, one of the 3 motorcycles that started out at the same time. So 3 motorcycles are there, first, second and third. And they are starting at the same time. Now he says one of the motorcycles was doing 15 km less than the first one and 3 kilometers more than the third one, right? So that means he's talking about this one, right? Since he is talking about this, with regard to this, I'm talking about this, and with regard to this, I'm talking about this. So let me consider this as the primary one, right? Now, so maybe I can say that this person comes up X kilometer. Now he says this is 15 kilometers less than the first one. That means the first one is traveling 15 kilometers more, so it should be X plus 15, right? And 3 kilometers more than the third one. That means this one is moving less, right? So that means this is X minus 3. Right? Now he says they arrived at the terminal point where they ends, obviously where the race ends, 12 minutes after the first machine. Right? So that means time after the 12 minutes after the first one and 3 minutes after the third one. Okay. He says there are no stops en route. Write the length of the course in kilometer. Right? Now suppose the length of the course is d. Right? I want to find out the value of d. Now I know distances. I know the condition related to time. That means I will form my equation involving time. Right? Now, let me write the time taken first. Now, if the distance is this, and we have, if the distance to be covered up is this, and this is kind of the speed, which is, says x plus 15. This time taken would be d divided by x plus 15. Right? Now, here the time would be d by x. Here the time would be d by x minus 3. Right? So, because I am talking about x plus 15 in 1 hour. So, maybe I am talking about the speed. Here I am talking about x kilometer in 1 hour. So, I am talking about speed. Here x minus 3 in 1 hour. So, I am talking about the speed. Right? The distance by speed will obviously give me time. Now, he says the second one arrived 12 minutes after the first one. Right? That means he took more time. So, we will say d by x minus d by x plus 15. That is 12 minutes. Mind it, we take the speed in kilometer per hour. So, that means I need to write 12 minutes in terms of hour. So, that is 12 by 60. First equation. Right? Second. He says the second one again is he arrives 3 minutes after the third one. Right? So, that means again he is taking more time. So, that means d by x minus d by x minus 3. Right? Now, this is 3 minutes, but I need to convert it into hours. So, that is 3 by 60. Right? So, I have two variables, two equations. I can easily solve it. How? I can see that d can be taken out common over here. D can be taken out common over here. If I divide the two equations, d would be cancelled out. That means I will get a quadratic in x. Right? Divide the two equations. You get a quadratic in x. Right? But we are not interested in the value of x. We are interested in the value of d. So, once you find x, you can find d. Right? And distance turns out to be 90 kilometers in this case. That is why the answer is 90. Alright, on to the next one. Now he says the radius of the circle is 8. Angle AOB, as in this angle, is equal to BOC, as in this angle, is equal to COD, as in this angle, is equal to AOD. Now, if these four angles are equal, that means each angle is equal to 90 degrees. So this is 90, this is 90. Maybe I can use it. Now he says that AO is 24, right? I want to find DS. That means I want to find out this. Now mind it, D is a point outside the circle, right? DS is the tangent. And from the same point I have DT, which is the tangent. Obviously DS will be equal to DT. So instead of finding out DS, I will find out DT. Why? Because AO is given over here, so maybe DT I can find out faster, right? Now, obviously tangent is given, I can join the point of contact with the center and this angle is 90 degrees, right? I am interested in this length. Okay. Now the thing is, what all lengths I know already. So this is radius, this is 8. This is 24, this is 90, this is 8. So that means this length is nothing but 16 root 2. Right? I want to find out this length. Mind it, here it is 90 degree, here it is 90 degree. Right? Using similarity of this triangle and the bigger triangle, right? I can write the statement that OT square is nothing but 80 into DT. You can easily write it, and in fact, we do remember the result. We have done this question so many times in class 9, right? So OT square is obviously nothing but 8 square is equal to 16 root 2 into DT. can find out the value of dt, which turns out to be 4 by root 4. Right? That means dt is this, so that means ds is this. Now, he says you need to find out 5 root 2 into ds. Just substitute it and your answer will be 20. Alright, on to the next one. Now he says a man buys milk at rupees 50 per liter. Then he adds water to it and then sells it at rupees 60 per liter. Now he says the percentage of water in mixture, if his profit in the deal is 44%, is given by A. You need to find the value of 3A. So basically you need to find out this, which is nothing but percentage of water in the mixture. Right? So what is happening is, let's check out. Now, their milk is therefore 50 rupees 50 per liter, and the adulterated milk, that is 60 per liter. Right? Now, I do not know how much milk did he buy, right? I do not know how many liters. So let that be it. Right? And I also do not know how much water he put it in the milk. So let that be y. So that means here the amount of mixture would be x plus y. Right? Okay. Now, let's see. He says the percentage of water in mixture if his profit is. Profit percentage is given to us. That means the final price, as in the selling price, minus cost price, whole divided by cost price, into 100 is given to you. Right? This is what I mean by the profit percentage. Right? So let me just substitute the values. Now he says selling price. Now obviously it is rupees 60 per liter. These are the number of liters, so 60 into this. Minus, now cost price, that is 58. Whole divided by 58 into 100. That is equal to profit percentages for it. Now obviously you are not able to find the values of x and y. We don't even need that. Right? We get a nice linear relationship between x and y, which is x equal to y minus. Right? Now, what I need to find out? He says the percentage of water in mixture. Percentage of water. Right? Now, water you added, right? That was what? Y liters. Now, in the mixture, what was the amount of mixture? X plus y. Right? You need to find the percentage of that. Into 100. Basically, you need to find out this. That means you need to find out this ratio. So, y is also there, x is also there. So, I would like, if they are just one variable, right? So, let me just substitute x as 5y. You already know this. So, this is y divided by 6y, obviously, into 100. This gets cancelled. My answer, 100 by 6. This is A. You need to find out 3A. So, into 3, that is why the answer turns out to be C. Alright, on to the next one. Now he says if polynomials this and this have 3 common zeros, then write the value of this expression. Now, obviously if I can find out A, B and C, my problem will be solved. Now where is A? A is here, B is here and C is here. Now the condition given to us is that polynomials have 3 common zeros. Mind it, this is a cubic polynomial, right? It will have 3 zeros anyway. And leading coefficient 1, leading coefficient 1. That means what? The factors must be like x minus alpha into x minus beta into x minus gamma. Right? And obviously zeros are alpha, beta, gamma. Now we know they have 3 common zeros. That means alpha, beta, gamma must be zeros of this polynomial. That means it will also have a factor of x minus alpha, x minus beta into x minus gamma. And additional linear factor. Right? Mind it, these factors are already present over here. Can you see what is happening between the two polynomials? Right? We can clearly see that this polynomial will be exactly divisible by this one. Right? Because all of these factors are coming in the factorization of this. So this polynomial is divisible by this. Alright. So x raised to the 4 minus 12x cubed plus bx square plus 216x plus c is exactly divisible by this. So one way is I can obviously divide it properly, or I can just write it like this. I know that this is the dividend, so my divisor is that x cubed plus ax square minus 18x plus 90. Now there would be some question, right? Now obviously this quotient has to be a linear factor, x cubed x raised to the 4. So that means this has to be x, right? Now I need linear factors, so that means I need the constant term. Mind it, here the constant term is c. right? C. So obviously I would not want to write the constant term as C by 9. Why? Because fraction gets involved and we are not a big fan of fraction. So what I'll do is let the constant term be K, whatever the case may be. Yeah, we introduce one variable ourselves, it's okay, we'll find out the value of that one. Big deal. Right? Plus remainder of exactly divisible, so that means remainder is 0. Now, we know that this is a polynomial, this is a polynomial. Left hand side, right hand side polynomial. That means the corresponding coefficient should be equal. Now, obviously, the coefficient of x raised to 4 is 1. Coefficient of x raised to 4 is 1. Obviously, there is no condition there. Now, let's talk about coefficient of x cube, which is minus 1. Right? Coefficient of x cube. Now, mind it, we'll start with this one. X cube should be multiplied by k in order to get the coefficient of x cube, right? That means here I'll get k. Then, let me see whether I can have x cube from here or not. X square x. I will get x cube. That means the coefficient is a. So, k plus a is my coefficient of x cube on the right hand side. Done? Now, let's move on to x square. The coefficient of x square is b. Now, coefficient of x square. Obviously, I will not start with x cube. I will start with x square. Now, this will need to be multiplied by the constant term. So, that is ak. Then, this one. This needs to be multiplied here. So, that means minus 18. This cannot be multiplied by anything. So, it's okay. Second relation I got. Right? Now, coefficient of x, which is 216, is equal to. Coefficient of x, I will not get from here. I will not get from here. Maybe I can get it from here. So that is minus 18k. Plus anything else from here. Yes, coefficient of x, so that means plus 90. Cool? Done. And last, obviously the constant term. Now, he says constant term is c. Here the constant term is 90k. Right? Using 4 relations, 4 variables are there. Let me find out the value. First of all, obviously I can see that k will turn out to be 7. Now k turns out to be 7, that means c turns out to be, k turns out to be minus 7. Here it is plus 90 or minus 90. Okay, wait. K turn out to be 7. Then, this is 90k, that is C. C turn out to be 630. Minus 90k क्यों आ रहा है मेरा? ये कैसे हुआ? Minus 90k की लिखा. K is actually turning out to be minus 7 from here. Yes. C will turn out to be minus 630. Perfect. B. Right. Now, instead of finding out B, I'll find out A. So, substitute K as minus 7. This will turn out to be minus 5. Substitute A and K over here. You will get B, which will turn out to be 70. You know the value of A. You know the value of B. You know the value of C. Just substitute it here and you will get the answer as 30. Alright. On to the next one. Now he says among all pairs A, B, where A and B are integers, which are solutions of this equation. So we are talking about the integral solutions of this equation. Consider the pair P, Q, whose first entry is the largest among A, B. Then write the value of this expression. Basically, I need to find P, Q. P, Q is nothing but the solution of this equation. But what kind of solution? Where the first entry is the largest among A, B. Right? So that means P or whatever we are looking for, or basically the value of X. Right? That has to be the largest. And I'm looking for the largest number in the integer. Right? Set of integers. So that means hopefully I'll be looking for the positive integers. Because if I can find the largest among the positive integers, that means that must be the answer. Right? Okay. So I need to solve this equation over the set of positive integers. Right? Since I'm interested in the largest of them. Now, when I look at the equation, that's x cubed plus x square y plus xy square plus y cube, that is equal to 8 into x square plus xy plus y square plus 1. Right? Now, any equation I want to solve, first thing that I'll use, that is factorization. Here on the left hand side, I can see that I'm getting two factors, right? I can see that is x plus 1, and then the second factor is x squared plus y squared. Right? No matter what kind of polynomial it is, polynomial in two variables, function is two variables, it's absolutely fine. I can solve it provided I can factorize it. That's why I try to factorize it. Now the problem is I have x plus y, then the factor is x squared plus y squared, right? Here I don't have anything in common. That's x squared plus xy plus y squared plus 1. X squared plus y squared, this is x squared plus y squared. Let me rewrite this. Let me rewrite this as plus y squared plus xy. At least similar term is there, right? Now similar term is there, and also along with x squared plus y squared, I have x plus y. Okay, and then xy is also there. Now these are familiar terms related to one another. How can I utilize this fact? Right? Now I can see x plus y is here, x plus y is hidden over here, right? X plus y is hidden over here, and xy will be what? Will be additionally hidden over here, right? So as I can see, x plus y, xy. Now it seems that if I substitute these two, x plus y, xy, I can convert this in terms of those two substitutions. So let me see what happens. Let me substitute x plus y as a, no, not a, because then I will get confused over here. Let me do that u, right? And then xy as b. Since too many terms are getting involved, so I selected the terms that is occurring, sort of occurring, and substituted it, right? So first thing becomes u into. Now x square plus y square, that would be nothing but u square minus 2b. U square minus 2b. That is equal to 8 into, again x square plus y square, I can substitute as x square minus 2b plus b plus 1. Obviously this becomes minus b plus 1. Right? So it becomes something like this: u cube minus 2ub minus 8u square plus 8b minus 8 equal to 0. Now you'll say, what is the problem? What is the benefit of this equation now? Right? Mind it, we need to solve this equation over the set of positive integers. That means I would solve this equation over the set of positive integers. Whatever the solutions I'm looking for, there has to be an integer. Right? Now, that means I'm looking for the value of u and v, which are integers. Do you think I can find the value of u easily from here? Of course not. U cube is there, u square is there. I do not know how to solve a cubic equation in two variables. I can't do that. Right? And it is a little bit difficult to just extract u. I can't isolate it because it's u cube is there, u square is there, and so on. What is easier to isolate over here? V. If I want u to be an integer, I want v to be an integer. So let me try to isolate v. Right? V I can easily isolate. It turns out to be, v turns out to be u cube minus 8u square minus 8 whole divided by 2u minus 8. Right? Now this is the thing. Mind it, v is an integer. That means this has to be an integer. Now this will be an integer when this quantity is exactly divisible by 2u minus 8. Right? Not every time, but for some values of u. Right? So my next logical step would be, I will try to divide u cube minus 8u square minus 8. Right? By this divisor. Now there is a problem. When I try to do this, right? When I try to do this, first thing that to do, here 2u is there, here u cube is there, right? I will have to use u square by 2. Now again in my quotient, I have a fraction, right? I have to solve over the set of integers. Now if I put fraction in the quotient, I will face a problem, right? Because this is not exactly going, it is involving fraction. That means I do not want to divide it like this. Not interested. What else can I do? Mind it, it would have been exactly divisible as in 2, 1, 2 if 2 factor was there, right? Factor of 2. Now how should I do this? Factor of 2. Somehow you should have a factor of 2. You should have a factor of 2. That means it should be an even number. Let me check. Do you think u is an even number? Let's see. Right hand side even. Right? This has to be even because right hand side is even. This will be even only when this is even. Now you are saying that u cube is even. If u cube is even, do you think u will be even? Yes. Right? Problem solved. Now we know that u is even. How should I utilize it? Now u is even, that means it is of the type 2k. Right? So let me substitute u as 2k. Let's see what happens. Right? So this v as it is. Now instead of u, put 2k whole cube minus 8 into 2k whole square minus 8 whole divided by 2 into 2k minus 8. Right? In fact, this expression reduces to, this expression actually reduces to, I'll write it here, 2k cube minus 8t square minus 2 whole divided by t minus 2. Why? I've cancelled out the factor of 4. So you can do that. Not a big deal. Right? We have reached up to this point. Now you can see that if this is an integer, this has to be an integer. Now if this has to be an integer, this should be exactly divisible by this. Now I can do it. Now I can divide this by this and fractions will not be involved. So I'm hoping that you know the division of polynomials. So I will leave that up to you. The expression ultimately turns out to be, I will erase it fast. It turns out to be, v is nothing but 2k square minus 4k minus 8 minus 18 divided by k minus 2. We like this number now. Right? Now, this is an integer. We know that k is an integer. So that means this entire quantity is an integer. That means for v to be integer, this quantity has to be an integer. Mind if this is 18 divided by something. If this is an integer, 18 must be divisible by k minus 2. Now, there are hardly any ways, right? Either k minus 2 can be 1, obviously, right? Or it can be 2, right? It can be 1, 2, 3, then not 4, then 6, then that's it, 9, and then 18, right? K minus 2 can take any of these values. But, mind it, I have to take those values for which v is an integer, so you will check that. And for which u is an integer. But if k is an integer, automatically u will be an integer. Look at it. Right? So, I will get the corresponding values of u and v. You think my question is solved? No. You substituted something as u as v. Right? This thing. Once you get the appropriate values of u and v, you will solve for x and y. And x and y will actually turn out to be x equal to a and y is equal to 2. This is the largest of the solutions. Right? So that means when we are talking about this solution, which is P as 8 and Q as 2. Substitute and obviously you will get the answer. And answer turns out to be 38. Alright, on to the next one. Now he says if summation of this is equal to this, you need to find out the value of a plus b by 6. So basically I want the value of a and b. That means I need to find out this. Right? Now, first of all, let me try to study the expression inside the square root. It is 1 plus 1 by k square plus 1 by k minus 1 whole square. Right? Now, very obvious step would be that let me take the LCM. So, k square into k minus 1 whole square. Cool? Now, obviously, I'll get here k square into k minus 1 whole square plus k minus 1 whole square plus k square. Right? This is the quantity inside the square. Mind it, when I open this up, the numerator becomes k square minus k plus 1 whole square divided by k square into k minus 1 whole square. First square. Right? Now obviously I will be considering that these quantities, this quantity is positive. So I can write this as k square minus k plus 1 whole divided by k into k minus 1. Right? I need to take this summation where k varies from 2 to 50. Right? Now, I need to add the series. Mind it, we have k over here, we have k over here. Numerator, denominator both. I'm not interested in that. I would want k to get in just maybe numerator or denominator. Most probably in denominator. So that I can use the method of telescopic sum. Right? So what I can do is, I can separate out the terms over here. As you can see, k square minus k. k square minus k. So let me separate out. So this is k square minus k plus 1 divided k into k minus 1 divided by k into k minus 1. Now mind it, this is nothing but 1. Done. Now I want the summation of this where k varies from 2 to 50. Right? Now obviously 1 will come in the first term, will this come in the second one, and so on. So let me just forget about 1 for the time being, because how many terms are there? 49. So 1 will come 49 times, so 49 plus summation k varies from 2 to 50 of this term. Now obviously I would want that I can write this as difference of two terms and consecutiveness should be there. Now k minus 1 k, consecutiveness is there. Now difference of two terms. Obviously I can write this as 1 by k minus 1 minus 1 by k. Check it. K minus k minus 1. So numerator will have 1, which is there. So I can write this as this. Right. It is very easy to write this as this. Now I'm just doing the reverse step. Very logical. Right. Now, how will this help me out? Let's see. Right. Let me put k as 2. So I'll get 1 by 1 minus 1 by 2. Let me put k as 3. I'll get 1 by 2 minus 1 by 3. Then next one, 1 by 3 minus 1 by 4. Can you see what is happening over here? So on. The last would be 1 by 49 minus 1 by 50. Now I can see the terms get cancelled like this, like this, like this, like this. So I'll be left with this one and this one. So sum of this one will turn out to be 1 minus 1 by 50. Mind it, do not forget your 49 over here. So 49 plus 1 minus 1 by 50, that is 49 by 50. As you can see, we can take 49 common. I'll get 1 plus 1 by 50. Right? Same form, just substitute the value of A and B and you will get the answer as 30. Alright, on to the next one. Now, he says in triangle ABC, this is 90 degrees. AD is the altitude. DE is perpendicular to AC. DF is perpendicular to AB. Right? AB is given to us, BC is given to us, and we need to find EF. Right? Okay. Now, I want to find out distance. Now, first of all, let me notice. I have 90 degree over here, I have 90 degree over here, I have 90 degree over here. That means I have 90 degree over here. That means it is definitely a parallelogram. Parallelogram with one angle equal to 90 degree. In fact, all angles equal to 90 degrees. That means it's a rectangle. Right? Now, I need to find out this length. This is the diagonal of the rectangle. Now, we know that the diagonals of the rectangle are equal. That means EF will be equal to AD. Right? So, instead of finding out EF, maybe I can find out this length AD. Now, let's see what AD is. AD is the altitude of the triangle. Now, altitude, that means I can use area. Right? So, let me consider this as the base, this as the altitude. I can write the area as half into 75 into AD. Right? Now, if I want to find AD, that means I need to set up an equation. That means I need to find area using something else. I took this as a base. Now, I know this is also 90, so that means I can take this as a base. So, half into 45 into. I do not know this length, but it is nothing but 15 into 3, this is 15 into 5, this has to be 15 into 4, which is 60. Right? From here, you can find AD as 36. Now, if AD is 36, EF is 36, which is the answer. Alright, on to the next one. Now, he says write the sum of digits of a 4-digit number, which is a perfect square, such that its first 2 digits are equal to each other and its last 2 digits are equal to each other. Right? First 2 are the same and then last 2 are the same. And the number is a perfect square. Now, I know that any perfect square will either end with 0 or 1 or 4 or 9 or 6 or 5. Right? So, that means at these two places, so a unit place can be 0 or 1 or 4 or 9 or 6 or 5. Right? So, let me start with the 0, 0 case. Right? Because if this is 0, this has to be 0. Condition is given. Now, first 2 digits are equal. So, that means obviously it cannot be 0, 0. It can be 1, 1. No, I know this is not a perfect square. Right? Because the thing is, it's 0, 0. So, that means it would be a square of like 30 square or 40 square or 50 square. right? Now 11 is not a perfect square, right? 12, 22, again not a perfect square. 33, no. 4, 4, no. 5, 5, no. 6, 6, no. 7, 7, no. 8, 8, no. 9, 9, no. These are anyways rejected. I don't even need to check it, right? So that means my 0 case is done. Now let me take one, right? Now mind it, I know it's a perfect square question, right? In class 10, we have studied that any squared quantity is either of the form 4k or 4k plus 1, right? The number which has 1, 1, that means it is of the form 4k plus 3, right? Definitely this number cannot be a perfect square. Done. So that means even 1, 1 is rejected. So let's come to 4. Right? This I need to check. So first, obviously, I'll check for 1, 1. It's not. Then you can check 2, 2, 2. Again, it is not a perfect square. Then 3, 3, 4, 4, not a perfect square. 4, 4, 4, 4. This is definitely not a perfect square. Then 5, 5, 4, 4, not a perfect square. 6, 6, 4, 4. You need to check these. Not a perfect square. 7, 7, 4, 4. You will realize it that this is nothing but 11 into 8. 88 whole square. Right? So that means this is the required number. He says write sum of digits will obviously not be